I'm John Wilker, the organizer of 360 IDEP. I hope you enjoy this session recording, but first I wanted to mention one thing. We've served the community since 2009, and over the past few years we've had to take on debt in an effort to keep the conference alive. After several unforeseen challenges, not the least of which is a pandemic of indefinite duration, we've had to make the hard choice to end the conference as we're now facing over $100,000 in debt. As a result of requests from the community of how they can help, we've created a GoFundMe campaign. If you're inclined and able, please consider donating to help keep 360 IDEP going. The QR code after this will link you to the campaign. Thank you. Enjoy the recording.
Times in the past just for skiing at Loveland. So I just wanted to start off this presentation with a little video of me skiing. Looks like the audio's not coming through, but that's okay. Yeah, this is me recording with one hand, poles in the other, and just going down a slope. So yeah, Loveland is my favorite place to ski just because it's pretty affordable and it's like a nice small knit community, so it's pretty cool. So if you haven't been to Loveland, be sure to check it out sometime. If you come back in the winter, great place to ski.
Is this a standard blue, or is it like a blue black, or
I would say this is like mostly a blue. Yeah. Mm-hmm. But yeah, if you guys have any questions during the presentation, feel free to raise your hands and I'll answer your questions as I go. I was skiing. Yeah. So today these are the 4 subtopics that I'm going to cover. Give a brief iOS memory refresher, talk about ARC and cycles, go through some Xcode memory tools, the usage viewer and graph, show some common code pitfalls and some example code, and do some live debugging. Hopefully that goes well, we'll see. And then identifying and fixing those leaks during the live debugging. So let's start with some background knowledge. So sometimes when we talk about memory leaks, you might be like, what's a memory leak? Or I forgot. So just a quick refresher. So does everybody know what ARC is? Quick show of hands. Everybody knows? Okay, yeah, so ARC is just automatic reference counting. So usually Swift does this for us under the hood. We don't really need to think about it, it just happens, and we're glad that it works. In this example, I just want to show 2 classes that somebody could create and how you could create a reference cycle using these 2 classes. So in the bottom here, I'm just instantiating 2 variables, one of each class, and then I'm assigning a property in each of the classes to each other. So the person class has an apartment property, and then the apartment property has a person property, and you're assigning them to each other, and this will create a reference cycle, a strong reference cycle. And this is something that you don't want to do. I'm not sure why somebody would do this, but if you do this, you'll create a strong reference cycle. So this is what it looks like in memory. You see that those 2 arrows connecting to each other, that's the strong reference cycle, and that's what we want to avoid. So in order to do that in this example, what you'd have to do is just make one of the variables that's referencing the other class a weak variable. So here I chose the apartment class. I made the person variable a weak person. So that will change one of those arrows to a weak arrow, and you've broken the strong reference cycle, and you won't have that memory leak associated with that. So here I just wanted to show an example reference cycle that I had in my code, and you can see there's a bunch of arrows pointing to different things in memory. The lighter arrows or more gray arrows, those are the weak or unknown references, and the stronger white or lighter gray arrows, those are the strong references. So the part that I wanted to highlight was at the top. There's a reference cycle, and then if you tap on that reference cycle, you can see there's a capture, and then there's a request, price, and callback context, which is just a simple closure, and that is causing a reference cycle in this memory snapshot. So next slide. Does anybody have any ideas why you'd want to debug memory, or any reasons why they debug memory? You can just shout them out if you have any thoughts. Yep, that's one. Rent crashes. Memory leaks, yep. Speed, yep. Improve app performance. Unexpected behavior, yep. Those are all good examples. So the list that I came up with was less crashes, decrease app memory footprint, keep the app functioning smoothly during long runtimes, easier to debug other problems, more reliable app behavior, and it's fun to solve the issues. So let's hop into some Xcode memory tools. So thankfully in Xcode, we don't have to deal with actual memory addresses when we're debugging memory. They have some pretty cool tools that we can use that make it a lot simpler. But there's just a basic question: who do you think would win? Print statements, or actually going through the memory debugger and going through every single address? So the first tool that I use in Xcode for memory debugging is the memory usage viewer. So here you can see the graph of memory over time. You have your memory use. That shows the total amount of memory on the device. And then you also have the total memory that's being used at the moment, what apps are running, other processes. This snapshot was on a physical device, so there's about 4 gigabytes of memory, but if you're running on a simulator, you'll get your Macs or laptops total memory, so that can be false positive, or it could show you a little bit more memory than you're expecting. And then at the bottom, you just have the time and then the amount of memory usage over time. And the next tool is the memory snapshot graph. So I'm just curious to see how many people know about the memory snapshot graph or have used it in the past. Show of hands. A little bit less, but yeah, still most people, yeah. So this tool I think is the most helpful for debugging memory issues. Here again, you can see the weak references are a little bit lighter gray, and the strong references are a bit more solid whitish gray. So those can help you see where you have strong references and weak references. And on the left side, you can see all the objects in memory, and then you can go through each one. You can expand them to see individual instances, or just click on them to get an overview. So then I'm going to go into some common code pitfalls. So usually when you're debugging, you have to look through the code and you have to find out where the problems are. So we can be like Liam Neeson, that we just keep trying until we fix it. So here, this is the first piece of example code that could cause a memory leak. And I'm wondering if anybody has an idea what's the issue with this piece of code. Yeah, that's right. So here in the notification block, we have the notification, but we'll have a strong reference to self inside of that closure block. So what we need to do is add a weak self in front of it, and then make self optional, and that will avoid that strong reference cycle inside of this notification block. And then we have this piece of code. Does anybody have an idea what could cause a strong reference cycle or memory leak in this piece of code? Yeah, that's true. You have to make the delegate a weak delegate, and then you have to make sure that you conform your protocol to any object so that the compiler won't give you an error when you're doing that. So this is how that looks. And this will avoid a reference cycle between this delegate or presenter and then whatever's calling that presenter, the viewer, the class, whatever's going on there. Then we have something like this. This one, it might be a little bit more obscure, but does anybody have an idea what could be going wrong here? So for this one, the problem here is that we have a closure that's being defined inside of this some modal view controller. At the top, you can see the action handler. That's the closure, and then it's being executed in the tab action. But then when we're actually assigning that closure, we're referencing the same view controller inside of the closure as we are on this action handler is on that view controller, and it's being referenced inside of that closure. So that would also cause a strong reference cycle with the sum modal VC. So what you need to do is make that a weak reference. So just make define it as a weak modal VC, and then you'll solve that issue. So this one can be a bit tricky to spot sometimes, but what you have to do is add that weak modal VC to the capture list, and that will avoid that reference cycle there. And then the last thing I wanted to talk about was just large singletons. If you have any large memory that's being stored for a long time in your app, could be in a singleton, could be a cache. You just want to make sure that you're clearing that out at good times if it's not being regularly deallocated or cleaned up in other ways, but making sure that you're nilling it out and removing that memory if the user doesn't need it anymore. And then I have a couple steps that I run through for debugging memory. So the first thing I like to do is run through a flow in the app that I think has a memory leak, and I repeat it several times just to see if there's more objects being added to memory than I expect, seeing if there's anything going on there. And then I generate a memory snapshot graph through Xcode to see what all the objects in memory look like. Then I try to pinpoint any objects, classes, or views that shouldn't be there. Say if I go to the ordering screen and then I go back to the landing screen, I wouldn't expect any of the ordering objects to be left in memory once I go back to the landing screen. And then I click on the objects that I find that shouldn't be in memory and try to see if there's any strong reference cycles there, any strong references that could be causing that to remain in memory past when it should. And then if there are too many items, sometimes I like to narrow down a flow, just go through like 2 or 3 screens at the max, or 2 or 3 elements in the area, and try to replicate the exact point of where the memory leak is occurring. And then using all that information, you can start debugging and just trying different things in your code and seeing what remediates that reference cycle. So now I'm going to go into a live demo. So I'm going to switch from mirroring to mirroring. Let's see. There we go. Sorry, it might take a few seconds for that to load up. So here, just have Xcode open and then a simulator running. I'm going to show an older version of the Little Caesars app running in our QA environment. So I'm going to start that up. And the first thing that I want to show is the Xcode memory graph. So you can see right here, this is running right now, launching the app and slowly increasing. And then you can see, I don't know if, yeah, it might be hard to see at the top, but sorry, I can't make this bigger right now. But currently the total memory is 16 gigabytes, which is the amount of memory on my laptop. And then over here you can see there's about, like 12 gigabytes or so of other processes running. And so right now the app is pretty stable on the landing screen. This is with an order in progress. And then I'm gonna go through just a basic flow of the app. So going to a pickup store, I'm gonna start a pickup order, put something in my cart, and then I'll just go back to the landing screen, the home screen. So you can see here there's a memory spike as I was navigating through those controllers, and then it went back down to a more, just a bit lower area. So there are some things being cached, so those things would be stored in memory still, so it won't go back to what we initially started with, but hopefully we get as close to it as possible, so we create a good flow for the user doing that. So the next thing that I want to show is generating a memory graph. So what I'll do is go to the ordering screen. I think there's a memory leak on the screen, so I'm going to go add a few things to my cart, check out the items, add to cart, scroll through the menu a bit. Let's see. Then go to my cart, so you can see the items I have in there, and then I'm going to go back to the landing screen. So here on the bottom, you can generate a memory graph using this button. So I just tap on that, and then this will generate the memory graph. This takes a few seconds to load, but. Mm-hmm.
They deliver?
They do, but we use DoorDash, so. Oh, deliver here? Yeah. So right here on the left, you can see all the objects in memory. And if you scroll down, you can see here there's some purple triangles. So those just indicate that there's there's runtime issues, and you can see here all the different runtime issues that are being tracked. And then if we go down to those elements, let's select one of them. So I'll select one with the triangle, and that triangle usually indicates that there's a reference cycle. So you can see here the reference cycle. And then we can zoom in to where we have the strong references. And then I'll tap on this too. And then you can see here we have this closure causing a strong reference. So now that I've pinpointed where that issue is occurring, it's happening in the order menu item cell V2, then I can go into that file and try to look at that code and see if I can find any issues with it. So I'll search for that code. And we can look at it. Is that code large enough? Can you guys see that okay? Okay. So then here you can see we have this request pricing callback type alias, and then here we have this request pricing callback. So this is being used inside of this cell. And you can see here where when you add an item to the cart, this callback is being called. And then, so here it doesn't look like we have any issues with the closures and how it's being called, but I can do a quick search to see where else this callback is being used. So I'm going to go to the order menu view controller, which is the main view controller where it's being used. So you can see here we have a weak self, and this one looks pretty good. And then down here we have cell.request pricing callback, so this is being called on the cell. We have the weak self. But if we scroll down here, we can see we're using cell inside of that closure. So that will be a problem. So what we want to do here is add a weak cell. And then we have to make cell optional. So we can no coalesce it for this function. And then I'll rerun that and see if there's any changes in the memory snapshot once we do that. So it'll take a few seconds to build again, but let's get that going. So I'll try to run through a similar flow, just going to the ordering screen and adding a few items to my cart, looking at the item details. So we can start the order, pick up, and then let's add an item to my cart, add it to order, scroll down a bit, add another item, this item added to my order, and then let's go back to the landing screen. Okay, then I'll run another memory snapshot, and let's see if anything has changed. So we can scroll down here. If you look, everything's in alphabetical order, but there are no more order menu items, V2 cells inside of the memory snapshot, so that looks good. And it looks like we resolved that memory issue by adding that weak cell. So that's one way to verify that that has been solved. But the other thing that you can also look at, I didn't show any before, but you can also take a look at the memory usage graph and see if that memory usage has decreased a little bit since those items have been released from memory now. You should be able to see maybe a slight difference. When I was testing it before, I saw maybe like 1 or 2 megabytes of difference with that data being lost versus freed correctly. So the next flow that I want to show is, let's restart this. So we'll look at a different part of the app. Going to the account screens. So I've already logged in to the app, so we can go directly to the user's account. And I'm just going to go to this account screen a few times, making sure that's being freed from memory correctly. And then let's go to the profile. And then just repeat that a few times. Should be good. So then once we return to the landing screen, we'd expect that all the account views would be removed from memory. So run the snapshot again. Let's see what we get. So if you can see at the top here, we have the account info item cell that still seems to be remaining in memory. And then we also have the account info view controller, which is the main view controller that appears with the profile, password, so on. So this seems to be a memory leak as well. So if we go to this view controller, we can try to see if there are any strong references in here. So if you look, you can see there's the account info item cell. That seems to be okay. Look through a different instance. Seems a little bit bigger. So not too much here. So the place that I would start looking is in the account info item cell, and just take a look at that, see if there's anything that looks suspicious in there. So let's start at the top. So you can see we have a navigation context delegate. That seems to be okay. We have a view model. And then go down, go down. That seems to be okay. So then let's look at the main view controller itself. Controller. So let's start at the top here. So you can see here we have a view model. That looks fine. Scroll down, scroll down. Looks good. Yeah, that seems to be okay too. But let's look at the view model itself, because that's also being used in both places. So we can open up the view model. So here, I can see just right off the bat, we have a protocol, account info view model delegate, and this protocol seems to be a bit suspicious. And as you can see down here, we have a delegate, but it's not marked as weak. So what I'd want to do is mark this as a weak delegate. And let's see. So we can build that. Oh, but then we get a compiler error. Weak must be applied to non-bound, non-class bound. Or weak is being applied to non-class bound protocol. So what you have to do is add the any object up here. And then that will make that error go away. And then we can recompile the app and see what changes we notice in the memory snapshot. So I'm going to go through the same flow again, just going through the account section of the app and trying to see if I can make sure that that account info view controller has been removed from memory successfully when I return to the home screen. So open it a few times. And then let's run this snapshot again. So as you can see here, there are no more account info view controllers in memory, but now it looks like we might have another issue at the top. So what I want to do is look in here, and I can see, oh, there's still this reference cycle that's being created, and it looks like it's being caused by some closure, and I can see here there's a tap action and capture. So this is pretty common when you're debugging memory. There might be 2 or 3 issues layered underneath one issue that you find. So even though you resolve one thing, you might have to go back and take a look at something else. So if I wanted to take a look at this, I'd go back and search for this tap action and see where that's being used, and I could fix that as well if I wanted to. So that pretty much wraps up the live demo portion I had. Yeah, the other thing that you could do is actually use a physical device tethered to your laptop and run your app through that, so then you'll get a more accurate representation of the memory on your device and the total memory that the device has. But using the simulator usually works pretty well to get a good idea of what's in memory and how those things are being freed and deallocated. So back to the presentation. So. Okay. All right. So I have a few tips when debugging memory, and just some things that I would consider when doing this type of debugging. The first thing is, if you want to, inside of a closure, you can use a guard self equals self, or let self equals self, and then return. So this will just short circuit that closure and make sure that you're not going through all of that code. So it can, just make it a little bit faster if you want to, and then you don't have to make self optional inside of your closure. So sometimes I'll use that for larger closure bodies. Then the other thing is there's weak and there's unowned. But I prefer weak to unowned because if you use unowned, there's still a chance that your app can crash. So unless you're really sure that something is unowned or needs to be unowned, I would generally prefer to use weak. And then the last thing is you can do a basic text search in your project to find any problematic code. So what I did in our project was a search for protocols and make sure that they were all conform to any object, and also go through and try to find any delegates that weren't weak. You can also do that with closures, like try to see if their closures have any strong references to self or referencing the objects which they're defined on. So at the end of this talk, you might think, weak self, all things, but yeah, you want to be a little bit careful with that. So there's this diagram I found online where you actually need to use a weak self and a closure, but in practice, I feel like this might take too long to go through every single step. So what I usually do is just test it out, go through my code. If I see a closure that looks problematic, I'll just test out that area and generate a memory graph, see if there's any strong reference cycles or if that object is retained in memory after it should be deallocated. And if I do find something, then I take a look at that closer and see if a weak self will resolve that issue. So in summary, I would say double check block notification observers. I generally prefer to use just simple selector notification observers, so you don't have to worry about having strong reference cycles in your block, but sometimes you have to use a block notification observer. And then always use weak delegation protocols, and then beware of referencing self or any objects in your closures. And that's about it for my presentation. Any questions? No, this is all old code, so these issues have been resolved. So I was just showing some code or some issues that I solved in the past, and how if you have code that's similar, you can resolve them. Was there a question on this side? I guess usually for me, if I'm looking at like a certain area of code and maybe I'm like refactoring something, then I'll look at that area a little bit more closely and try to see if I can find something just by glancing at the code. Like if I'm refactoring, I'll just look for the delegates themselves, and if I see something that's problematic, then I'll just go through and take a memory snapshot and see if I can find anything that looks wrong in that area that I'm refactoring. The other thing that I like to do is if we like add something new to our project, like maybe we're updating our animations, we're adding like a new animation framework, just going through and then testing that framework, like what replaced the old code, and making sure that the new code's not causing any memory leaks or any memory issues with the new changes that you're making. So, yeah, go ahead.
I was wondering if you found any effective ways to automate leak detection in jars. It seems like the UI automation with our all the exercise the app.
I haven't thought about that too much. I think maybe the one thing that you could do is just take a total memory usage graph and then try to kind of compare it before and after if you're doing the same flows. But memory can be a bit finicky, so I would think there'd have to be like a certain percent similarity or certain range that you would look for. But I think maybe taking those snapshots and trying to see if there's like a big increase in memory use in the same flow, that could give you an indication that there's something that needs to be looked at there. No problem. Anything else? No. Yeah. Oh, sorry.
Can you go back to the slide of the house and the apartment versus the
Yep.
I just have a philosophical question I want to ask.
Okay. This one right here.
So when I look at that, the way I use about it is what I think is an apartment's always going to be owned by someone, right? Either a company or the government. It's always going to always own that. But not every person is going to have an apartment. So I would just put the week on the apartment. Like, do you go through that like local reasoning, or do you just like make one of them week doesn't matter?
Yeah, I wouldn't personally go through that reasoning, but it does make sense when you think about it that way. If you're like trying to understand your code and like think through it more, and yeah, have it like make sense to anybody that's reading it. So that's a good thing to think about too. Yeah, and I haven't checked the Slack group, but I'll take a look at that too. And if you guys have any questions later, you can feel free to Slack me or leave any comments. Okay, thank you. And then I just want to say a special thanks to Dave and Amar. Dave was the one who got me to submit my idea to speak here, and Amar for supporting me, and the Little Cedars iOS team. Also, 360 IDA for making this all possible and having us all here for these couple days. So, thank you.